All right, so we're going to learn about inverse matrices today. So the first thing that we should know is like how an inverse works and why it exists. So the first thing that we have to know is the identity matrix. So basically, it's a square matrix with a diagonal of ones. And all other entries are zeros. Okay, so basically you can have an identity matrix that's a 1 by 1, so I'm going to call it I1. That would just be the matrix 1. Okay, so that's not anything really special. We have the identity matrix I2. That's a 2 by 2 matrix. It would look like this. And we have an identity matrix that's a 3 by 3. And so it looks like this. So we have this whole diagonal of ones. Every other entry is 0. Okay, and this could keep going for I4, I5, I6, and etc. But we're just finding inverses of 2 by 2s and 3 by 3s. And we're just doing 2 by 2 today. Okay, so basically the definition of an inverse is the product, and I'm going to say of matrix A and A inverse is the identity matrix. So basically, we have this whole multiplication process for A and A inverse, and we get out the identity matrix. So if that happens, they're inverses of each other. So if we ever wanted to verify that two matrices are inverses of each other, we would have to multiply A times A inverse. We should get out the identity matrix. And we also have to multiply it in the other way. So this is the only way that the commutative property works, like I was talking about, I don't even know when, yesterday or maybe Wednesday. So I'm going to make a note of that. Oh gosh, commutative property only works for inverse matrices. Okay. Oh, buddy. So yeah, you'll have to verify that two matrices are inverses, so you'll have to multiply both ways, so flip them around. And then you'll have to find the inverse of a 2 by 2. And you learned how to find the inverse of a 2 by 2 in Algebra 2 class. This is just a refresher. So my definition is going to be this. So given matrix A, and I'm going to identify it as A, B, C, D. The inverse is given by, oh my word. Okay. So the inverse of A, we have to multiply 1 over, and that's AD minus BC. And this whole piece, that is the determinant of A. So this whole cross-multiplying thing. And then if you remember, we do this whole flipperoo situation. So D and A switch locations. B and C stay where they're at, but they change to negative B and negative C. So that's how we're going to find the inverse of a 2 by 2 matrix. So it's a fairly simple process. We just have to do the math to get there. So we'll learn, this doesn't work for 3 by 3, unfortunately. There's a more interesting way to go about it, is all I'm going to say about that. And it's going to use elementary row operations, which you should have practiced the other day. Okay, so we want to verify that these two matrices are inverses of each other. So I'm just calling this matrix A and matrix B. So the first thing that we need to do is multiply A times B together. So I'm just going to rewrite the two matrices next to each other. And I'm hoping you know how to multiply matrices. It's not a complex process. So remember, we have to multiply the rows to the columns. So just starting with the first one, we have 5 times negative 3 is negative 15. Negative 2 times negative 8 is 16. Negative 15 plus 16 is 1, which is what should happen. I should be getting out the identity matrix. And then the next one is 5 times 2 is 10. And we're adding to negative 10, so that's 0. And then we have to move to the second row. So 8 times negative 3 is negative 24. We're adding it to positive 24, so that's 0 again. And then same thing, 8 times 2 is 16, minus 15 is 1. So that is verified. I got out the identity matrix. So this one way of multiplication shows that it's an inverse. We also have to prove that B times A is also the identity matrix. So we have to flip-flop these two matrices and do the exact same thing. So it seems kind of crazy that we have to do both ways, but some matrices prove one way and not the other. So that's why we have to do both. Okay, so same thing. So negative 3 times 5 is negative 15, plus 16 is 1. That would be 6 minus 6 is 0. And negative 40 plus 40 is 0. And 16 minus 15 is 1. So, yay, they're inverses. I'm not sure. I know the book has you verify. I want to say they have some that won't verify. So, yeah, just keep that in the back of your mind. Okay, so let's use this lovely matrix to actually figure out how to find the inverse. So this is the inverse, or the matrix A. I guess the first thing that I would do, because we're using this formula, I would find the determinant of A first, and then use that. So determinant is doing the 1 times negative 4 piece, that's negative 4, and we're subtracting it to 2 times negative 1, so that's negative 2, and negative 4 plus 2 is negative 2. Okay, so if we're finding the inverse, we have 1 divided by the determinant, negative 2, and then my matrix changes a little bit. So 1 and negative 4 switch locations, and then 2 and negative 1 switch signs, so negative 2 and positive 1. And then I even want you to multiply this negative 1/2 into the matrix, so negative 1/2 is acting as a scalar, so I can distribute it to every single entry. So the inverse of A is actually positive 2, positive 1, negative 1/2, negative 1/2. So this is the answer that we're going for today. So if you want to verify it, you could actually multiply your matrices together. You should get out the identity matrix, but I'm going to hope that I did that right. So that is all we're doing today. So here's your short assignment. It probably won't take you that long. So have a happy Friday.